Here are 3 tips for operator new in C++. Number 1. Don't use new like it's cmalloc. Many people who come from C think that new is just type-safe malloc that also calls a constructor, so they assume it returns a null pointer on failure. However, that is not the case, and new will always return a valid pointer. But what if it fails to allocate memory, you ask? Then it throws an exception, specifically standard bad alloc. However, if you want new to return a null pointer on failure instead of throwing, you can mark it with standard no throw to use the non-throwing version. Number 2. Always correctly free memory allocated with new. Now this one may sound like something you should already know, but a lot of beginners forget to free allocated memory with delete. Also, if you're dynamically allocating an array with new, you have to free that array with the array version of delete. Otherwise, you'll cause a memory leak and most of the time corrupt the heap as well. And finally, number 3. Don't use new at all. Just use RAII containers instead. RAII stands for Resource Acquisition is Initialization, and RAII containers are basically data structures that manage heap memory lifetime in their constructors and destructors automatically. That's how you make sure you never forget to free memory. For example, instead of using regular new and delete, use a unique pointer, which owns your heap allocated object and deletes it for you upon going out of scope. If you need multiple instances of an owning pointer that own the same object, use a shared pointer, which keeps a reference count, aka the number of currently alive instances that own the same object, and when the reference count reaches 0, that last instance is in charge of deleting the object. And if you need an array on the heap, you have absolutely no excuse for using new for arrays over standard vector. Now this doesn't automatically mean that raw pointers are bad. Raw pointers are useful, but only when you don't need ownership and only need access or modification. However, C++ also has a better alternative for pointers in most scenarios, references, but we'll save that for another time. So go ahead and subscribe so you don't miss out on that.